And those supercomputers are used for various scientific exploration, investigations, and data analysis, for meteorological study, for atomic energy studies, and a number of strategic applications. We do a lot of work in multilingual computing and digital preservation. So that is one of our areas where, and we have tried to apply multilingual computing also in the field of agriculture, when in course of implementation of various R&D projects. We have a very big activity in professional electronics, including VLSI, embedded systems, etc. And our activity in agriculture basically falls under this umbrella of activities within CDAC family. Then we are working on all kinds of software technologies, including free and open source software. We have a very big presence in the country in the cyber security, cyber forensic domain, and we do a lot of research, a lot of implementation, a lot of audit, and a lot of security operations centers in the country are developed by CDAC. We do a lot of work in health informatics, starting from drug warehouse management system, going to hospital management system. And of course, in the COVID time, a lot of innovations have come out from CDAC, which is on day-to-day use by various government departments. And we have a very strong wing on education and training, and with a special focus on emerging technologies in the field of information communication technology. So what we want to tell in this slide, that CDAC is a technology powerhouse, and a number of technologies have been deployed and used in the field, in the niche area of agriculture. So now, coming to our topic, is about sensors and sensing systems. So all of you know, but just for your refreshing, or maybe to root you to a formal thinking about sensors, as per American National Standard Institution, ANSI definition, sensor is a device which provides a usable output in response to a specified measurement. That is, you have to measure something, or you have to monitor some parameter, some physical parameter. Then that device, sensor, will be able to measure that, and output of the sensor will be a measurable quantitative presentation of the measurement. So a sensor acquires a physical parameter and convert into a signal suitable for processing. It can be optical signal, electrical signal, mechanical signal, electrochemical signal, biological signal. But there, the sensor will have a physical input, and at the end, to be used for presenting to the user, it has to have a electrical output. So input physical and output electrical. And this process is called transduction process. And that's why sensor has always a transducer as an integral part of it, like a microphone I am talking now. See, it's taking acoustic signal or sound signal as inputs. Now, that input is being converted, because output of the microphone is coming through a wire. So it is converted into electrical signal, and then it is entering into your speaker system through internet and other connectivity. And then you have the output of my audio is reaching you. So microphone is a sensor. So this kind of a number of sensors are there, which are appropriate for agricultural field, which we'll try to show you through some use cases. So basically, as I have told, that sensors will sense something, some physical parameter, and that can be acoustic, like in microphone. That can be biological or chemical, like there can be a fluid concentration sensor, or there can be a gas sensor, some hydrogen sulfide or sulfur dioxide, if you want to measure. So they will take that chemical or biological stimulus at input and create a electrical signal for your measurement, for your monitoring. Then the stimulus can even be electric, even charge, voltage, current. Suppose you want to measure how much current a motor is consuming in a particular operation, then you have to sense the current or electric field, conductivity, permittivity, all kinds of parameters can be sensed through electric stimulus. There can be magnetic stimulus like magnetic field, flux, permeability, etc. Then there can be optical stimulus like and that may enable through a sensor to measure refractive index, reflectivity, absorption, because these photo detectors are there. So they can sense the presence or absence of light. So they are using optical stimulus as the physical inputs. There can be thermal inputs in temperature sensors. The change in temperature is detected, and there can be mechanical inputs also: position, velocity, acceleration, force, strain, stress, pressure, torque, etc. So the takeaway from this slide is that any sensor, we can have multi-dimensional, multiple types, all kinds of stimulus, and through appropriate transducers, that stimulus signal is converted into electrical signal by a sensor. So these physical principles of this stimulus and conversion it through a transducer to electrical signal is governed by various physical principles that we have been learning from class 8 to our physics study in graduate level, postgraduate level. So lot of physical laws are there, which physical principles are there. They guide the transduction mechanism. There is no scope in getting into all these details here, but only to tell you that there are physical laws, physical science we have been studying, and these principles only are used within a sensor to really finalize the transduction mechanism. So sensors are omnipresent, and especially sensors are needed everywhere. Especially, these days we call Internet of Things or Internet of Everything, IoE or IoTs. And at the front end of any IoT, there has to be a sensor. And these days, these sensors are becoming omnipresent. It can be a smart home, it can be a smart city, it can be a smart agriculture, it can be a smart industry, it can be a smart digital healthcare services. Everywhere you need to monitor, you need to measure. Those sensors should be there everywhere, and in agriculture too, in every operation, there has to be sensors, especially because of the fact that the communication revolution is going to rule us in days to come. 5G is in the offing, where everybody will have multiple connected devices along with us, and every device will have a number of sensors. So, to understand sensors, to know basically what is sensors, and to have a realization of sensing systems are the key for any research and development, be it device specific, be it application specific, are going to be very important in days to come. So the when really you have to choose a sensor, suppose you have a specific application, you have to really choose what kind of sensors I am going to use for this application. I'll invite your attention to the right-handmost column of this side, where we have written sensitivity, range, stability. Stability means long-term stability. How long the sensor will work within the specified limits. Repeatability, that is the same parameter repeated times being applied to a same sensor should give a same results. Linearity, that is whether it can cover a wide range. Suppose you are using a temperature sensor where the temperature changes from 10 degree to 80 degree. So whether it's linear, whether the change, whether the transduction mechanism can handle that bandwidth, that kind of variation of that particular parameter. Then error, what is the percentage of error in your readings. Then response time. See, if a temperature sensor takes 15 minutes to respond, but your process temperature changes every 1 minute, then it may be very difficult to use that sensor. So response time is one of the major criteria to look at, and the frequency response, that the suppose your parameter value is changing in seconds, and whether up to what frequency the readings can really be acceptable for that device. So if you have to change any, select any sensor, please look for sensitivity, range, long-term stability, repeatability, linearity, error, response time, and frequency response. These are the major parameters. You should be very confident that the sensor you are choosing for a particular operation is having the acceptable ranges in terms of all these sensor characteristics. Then only your sensor, you can successfully deploy a sensor for any application. For example, temperature sensors. This is one sensor. All of us know that temperature sensor appears in building, chemical process, everywhere. Many physical phenomena depend on temperature. So we can often measure temperature indirectly by measuring pressure, volume, electrical resistance, strain, etc. also. So temperature sensor, actually, there may be a bimetallic strip, bimetallic strip type of sensor, where two different metals on application of some heat will expand in different way. And that way, there will be a bending happening. And these kind of sensors are called bimetallic strip. Why I have given this example? This is a very simple example. I wanted to draw that your stimulus is changing heat, and your sensor has got a physical law that expansion coefficients are different for different materials, and they will have a bending tendency as soon as you apply some temperature. So thermostats, etc., use on this kind of principles. Then there are RTDs for temperature sensors, that is resistance temperature devices. Based on these RTDs, you can measure very accurately the temperatures, and many processes, even in agriculture, we have used RTD temperature, and they are commercially available. Only before selecting the sensor, please go to the specification of the sensor and try to see that what your application needs, and whether these sensor specifications are catering to the need that your application demands for. There are some sensors called accelerometers. Accelerometers are basically used to find out the vibration. See, if we talk of agricultural processing, a machine is vibrating beyond certain limit or not, those kinds of things can be found out using accelerometers. They use piezoelectric mechanism that is piezoelectric crystals within them, so that the vibration frequency can be accurately measured using accelerometer sensors. And washing machines, heart monitors, car alarms, they all use accelerometers within them. So this is one important sensor. To really bring out the topic of sensor, I thought I'll just show you some sensors, like light sensors. Light sensors are used in cameras, infrared detectors, ambient lighting application. Sensor is composed of a photoconductor such as photoresistor, photodiode, or photo transistor, so that as soon as light is applied, some electrical parameter like resistance, suppose, changes. And as soon as there is a change in resistance, it is very easy by electronic engineers to capture that in terms of an electrical signal. And then that signal can be presented and correlated with the light or the intensity of light that has been coming onto the sensor. So here the stimulant is stimulus comes from lights. Then there are magnetic field sensors also are used in power steering, security, and current measurements on transmission lines. In the transmission lines, to measure currents, you use these magnetic sensors. And there are Hall effect sensors also. So they all use the physical science principles to really develop the transducers within. There are ultrasonic sensors are used for position measurement, sound waves emitted in the range of 2 to 13 megahertz, sonar, sound navigation and ranging. Sonar devices for these are used in underwater applications. Then radars, radars are used. They are also sensors. They also sense in airborne these aircrafts and all this. We use radars, or radars are used in, even these days, traffic radars are used to detect your signal. Doppler radars are used to find out whether somebody is overspeeding or not. So they also use some electromagnetic wave as the sensing stimulus. Then we are these days very familiar with photo gates, that is infrared sensors at the gates, whether you are entering or you are coming out. The infrared emitter and detector, they will find this receipt of signal and non-receipt of signal, and they will be able to signal whether there is presence of some object within or not. And they are all infrared sensors. They also use the optical stimulus here, optical stimulus in infrared region. So this is very commonplace these days. Then there are many gas sensors. I have shown here carbon dioxide sensors, but there are sensors for methane, there are sensors for mercaptan, there are sensors for hydrogen sulfide, and they use different types of technologies within them. Some use spectroscopy within, some use metal oxide semiconductors within, to really find out the concentration of the gas that is coming on the sensor surface. So there are a lot of gas sensors using chemical technologies also, chemical technologies, as well as spectroscopic technologies. So now, uh, having said all about sensors, so you need not remember anything, only remember three things. A sensor works on a single physical stimulus. A sensor has got a transducer. Output of a sensor is an electrical signal. Please remember all these three. And at this stage, please also remember that when we sense any physical parameters, we sense from nature or some process. And the process or the nature itself is analog in nature. So sensor input will be analog. It will be a continuous wave nature. And the electrical machines, computers understand only digital technology, 1010 technology. So sensor receives something analog, and to really interpret that signal by a machine, you need to convert the signal to digital format. And this is called analog to digital conversion. And there are a lot of steps within that. And this sensor, stimulus, transducer, and the electronic and electrical system that makes, that converts the analog signal to digital signal together is the sensing system. So a sensor cannot exist without a sensing system, and a sensing system cannot exist without a sensor. So when we talk of sensor, that means there has to be a sensing system following up. And that sensing system, the job essentially it does is the physical parameter, which is analog in nature, that is captured and then that is converted into digital format so that our machines, our mobile phones, our smart devices can really interpret that analog data in its own understandable form. And that's what is the sensing system. So having a little bit idea of sensors and sensing system, I'll now go to the agriculture domain. Now, sensors in agriculture. I have been given the topic where it is telling production, processing, and marketing. And in the domain of agriculture, for a layman like me in the field of agriculture, I am actually a computer scientist. So I understand production means it starts from soil, then application of fertilizers, then the management of plantation, starting from seeding to harvesting, and application of all kinds of fertilizers, pesticides, etc. And to do that, to support this, there has to be a lot of informatics. That is, you are calling in your term extension. That is provision of right information in right time to the right people. So this kind of production, if we can break it to soil, fertilizer, plantation, harvesting, informatics, and so on and so forth, in every step, there is need and proven application of various sensors and sensing systems, some of what that we have done, we'll try to show you in the following slides. Then processing to for a layman like us in the field of agriculture, we understand processing means after harvesting, you do some post-harvest storage or post-harvest distribution or post-harvest processing, like food processing. If you harvest mango, you produce mango juice means you are processing mango. So processing for tea, we have done extensive work on tea. So tea leaves are plucked and then they are processed to make the black tea that we have or green tea that we drink. So processing means post-harvest and wherever applicable, the kind of manufacturing and processing technologies using agricultural inputs. And then once processed, or once stored in the post-harvest, and then it has to be distributed to your target stakeholder. Then the marketing comes, and once again to a layman in the agri-marketing, I understand the quality is the first thing. If I want to buy apple, I'll go and try to see whether its shape and size is good, it's having good smell, if smell is coming, or if the vendor is kind enough, if he gives one piece, I'll try to test, and then I'll try to assess the quality. Then, of course, packaging is very important these days, and these days a lot of smart packaging technologies are available. Then, of course, auctioning and sales. Now, all these processes, and there will be a lot of microprocesses within this broad umbrella of operations I am talking of. Um, these uh, packaging, auctioning sales everywhere, there is some scope of application of sensors, and here also we'll try to share our uh, our experience of application of sensors. So now first, sensing technology in production. We have uh, done a very major project on application of wireless sensor networks for tea plantation. Actually, we have used there is a photograph and there are some write up in the slide, but I will try to draw your attention to the word wireless sensor network. Wireless sensor network. This is an extension of sensing system that I am trying to highlight here. Wireless sensor is sensors that will acquire data in remote locations in an agricultural field, will transmit the electrical signal in wireless route. So it will first acquire the data, then it will transmit through some communication protocol to a remote server, and there the decision support system will decide. See, the decision support system will have all the inputs from the sensors, and then it will have it will give the decision what needs to be done in terms of application of fertilizers or application of irrigation or application of water, whatsoever, based on the sensor inputs. And the sensors that we have used is for the soil in our particular project, soil temperature at various depths, soil moisture at various depths, soil pH, there are sensors for pH, then meteorological like humidity, this is normal ambient humidity, ambient temperature, and the solar radiation, there are sensors. Then we have used the camera also, vision sensor, and a pan, tilt, and zoom camera, which can really have a monitoring of the leaf canopy. And of course, we have done some exploratory study on leaf wetness sensor also. And sensor array will acquire the data, then wireless transmitter will transmit that data, wireless receiver at the remote end will receive that data will be acquired in a computer, and analysis will be done based on which the decision will be given. That's what I was trying to highlight in our previous slide. So working principles are like this. There can be n number of sensors, and there can be a gateway, there can be first level wireless nodes, and then there will be gateway, and there will be server. So multiple tiers of transmission of data, and can from a remote location, you can really find out what is happening on the field and take appropriate decisions needed for the field. And this is what precision agriculture is all about, to really apply optimum inputs as and when required in the right time. So these wireless sensor kinds of systems are very useful. And here, the decision support application, this kind of process flow we have used, where various data has been really taken from the field, and sensors data, then soil file, soil info, etc., crop files, and there can be some weather data also, and there can be some legacy data also that can be used in aggregating all the data together before giving the decisions. So these are the experimental site, and you can see these are the sensors. The topic of today's this thing. These are the kind of sensors, that is, they take analog inputs They have a PC interface, and they are all battery powered because they have to be deployed on the field, and they have a small antenna so that it can be transmitted to its nodes and the gateway. So this kind of sensors have been used: wireless camera, ambient temperature, soil moisture sensors. These are the devices, specific devices. They are the So these are the various types of sensors and their specification, the outputs, what is the range, etc. And of course, the other parameters like sensitivity, selectivity, long-term stability, etc. also have been studied for selection of the optimum sensor. There's a solar radiation sensors, soil sensors, then soil temperature, soil pH electrode. We have developed these sensors, and then pH transmitters. That these are the transmitters that data of the signal that is acquired on the field. Then pH electrode calibration methodology. We had a calibration methodology. Any sensor for your information has to be calibrated a regular periodicity. Unless calibrated, sensor values have got no meaning. Like your thermometer at home, you know that thermometer is giving 98 degrees Celsius, so you're okay. So in case it varies, then your whole decisions will go haywire. So sensor calibration is for specially any kind of this kind of agricultural use or industrial use needs to be calibrated on regular basis. Then this kind of camera we have used, where on the field, even these cameras have got infrared capability, so that in the night also you can have at what is happening canopy of the plantation. So these are all the photographs we got by like electronic vision system from the camera, what all disease outbreak, etc. are happening. Then these are the sensor boards that was used. So these photographs I'm only showing to give you an idea that a sensor and a sensing system goes hand in hand, and a it's an integrated solution that really may prove to be useful and meaningful for real users on the field. So we developed this entire system and things were deployed on the field. So I am trying to give you a feel of what this kind of sensor deployment means on the field. So this kind of sensing systems are used. Once again, this is the circuit for the sensor. I am not going to inviting you to go into nitty-gritties of this circuit and components. But I once again tell you, this is sensing system. This converts the analog signal to digital, and there are a lot of other steps. These steps and in this sensing system, which really permit you to use sensor for a real practical application. So these are the on-field this deployment things. So they are all IP65 compatible modules, because no dust, no rain, no kind of, but except vandalism. The vandalizers nobody can. But otherwise, they are having long-term proven operational ability without any disturbance. Kind of, we had to cover the camera with this because, and there was a lot of monkey menace coming, so we had to put a this wire mesh also around. So these are the decision support system software screen, and the various parameters online you can monitor, and decisions also can be automatically taken by software in terms of site scheduling, in terms of fertilizer application, in terms of any other dolomite application, or any other things you want to apply. So these are the software screens. So these are the pictures captured that how beautiful, how these predators on the tea leaves are moving. So from our camera. So now one point I wanted to this thing right here, that accurate information recording of soil, plant, and associated environment is a key feature of agriculture 4.0. I call it, if you apply sensors, if you use technologies, if you really apply cyber physical system technologies, then you really uh, go to agriculture 4.0, because there these days industry 4.0 people are talking of, in agriculture 4.0 people are talking of. So these are the basic inputs, and of course, information regarding crop yields, soil properties, crop nutrients, crop canopy volume, biomass, water content, pest conditions. These are also need to be measured further through a lot of sensors, and we are through different projects trying to really aggregate all this information together so that the agriculture in our country can be really converted to smart agriculture. And in crop production, these are the various, in a nutshell, there has to be field-based sensors. There can be additionally biological sensors. There can be spectrophotometers. Like spectroscopy is a very important measuring technique is coming up very strong in the field of agriculture. So spectrophotometers in its various variants need to be deployed in the field to really measure many parameters, maybe the biochemical constituents of any crop, etc. Then, of course, machine vision, that is camera, deployment of camera onto the in the field is very important. Then airborne multispectral and hyperspectral remote sensing, that is drones. Drones are coming as a very important plant growth monitoring mechanism in our country. A lot of laboratories, ICAR labs, even CDAC, we are doing a lot of work on airborne, multispectral, and hyperspectral imaging systems using drones. So maybe in a couple of years, we will have very proven methodology to monitor and control the plant health on for any crop in this country using such technologies. Of course, satellite imagery is there, important thing. Then thermal imaging, only IR imaging is coming up very strong in terms of finding out the pests and disease prone crops. That can be very early infestation using thermal imaging. Then RFID technology is coming up is being used, in fact, for from harvest stage itself, to have a mark every crop or crop package. Then machine olfaction system. Machine olfaction system means the electronic nose systems, which can really have the sense of smell, and electronic tongue system, that is the sense of taste. So these are the two things. Intense research is going all over the globe to electronically find out smell or aroma as well as taste of any agricultural or food product, and or any beverage. And their machine olfaction system also, we are going to find commercial systems in the days to come, which essentially uses, once again, specially sensors and sensing technologies. And of course, ESA based electrochemical systems. There are electrochemical sensing which is going to come in a big way, where you can electrochemically find out the quality of any agri produce, any fish or meat produce also. These electrochemical sensors have got a lot of potential in days to come. This is high resolution remote sensing imagery, which can really uh, give lot of inputs in terms of plant, that is crop yield prediction, crop yield forecasting, etc. So I already mentioned this. Then, of course, I have told in the production sector, as far as application of sensors is concerned, informatics play a very useful role. And web-based, web-enabled agricultural information dissemination system is one of the key areas which CDAC has worked jointly with Vista Agricultural University, and the web-enabled information dissemination system has been developed in 7 languages of Jharkhand, and this is being really used by government of Jharkhand now. This portal has been taken over by government of Jharkhand, and day-to-day content management is done by Vista Agriculture, and this provides a lot of information about agriculture, animal husbandry, and forestry for the farming community. That is for the farmers. It goes up to the farmers. Various means like web, mobile, etc. Then this is a mobile-based information dissemination done. That is right information, right time. These are the various screenshots portal that is up and running. You can go to Vista Agricultural University portal, and from there you can go to e-agriculture, and you will be able to find this information system. Then one more area I will tell you in the field of agriculture, coming up strong, that working in area, that is robotics agriculture. We have started a project where an autonomous robotic vehicle, we have started designing jointly with IIT Kharagpur, then KCT Coimbatore, Vista Agricultural University together, and this vehicle is already developed and it is deployed in the shortly, where you can automatically, it can plan its mission and go to the or the in a very muddy field of paddy cultivation. It has been developed for paddy cultivation. It will go into the field. This will find out the health of the plant. It will find out its growth rate, and it will also decide automatically whether some fertilizer or some pesticide needs to be really applied. The autonomous vehicle will be equipped with these pesticide applicators as well as fertilizer applicators, automated application of them to specific plants. Not that generally what happens in a big plantation, a lot of wastage of fertilizers and extra application of pesticides is done. But here, vehicle will automatically navigate through the field, and it will apply only to the exquisite portion of the plant wherever required. So this project, we are very hopeful that one more year we will be able to transfer the technology and deliver it for Indian agriculture. Then, of course, weather forecast also we have done micro weather forecasting developed in collaboration once again with Agricultural University, and this is now available for the entire state of Jharkhand. And the weather information is no IMD issues only up to block level. Our system gives weather forecast daily as well as hourly for a panchayat level, up to panchayat level, that is 4 kilometer by 4 kilometer. That area, any panchayat, you can have what is going to be the weather forecast. And this has been developed by CDAC Kolkata, CDAC, Pune, and these are together. And this is up and running. You can go to Google Play Store and download this app and find out what is the weather forecast for that. Then 16 weather parameters are forecast through this app. So I have told that agriculture production, to our understanding, consists of soil, then putting the seed there, and then managing plantation, and then harvesting the crop. And to manage all those things, you give some right information in right time. And I have tried to show you that right from soil to the plant monitoring to the harvesting, there are scopes and proven applications of sensors and sensing using aggregation of technology like communication, like sensing, like computation, like data processing, but effectively that is that shows that there are a lot of possibilities and more focus, more research, more applications, and more institutes should come in this field so that India really develops a smart agriculture system in our country. Now I'll come to few highlights of sensing technology in processing as understood by us. And we are, I have told you, we have extensively worked on the tea industry because that being one of the major cash crops, our country, eastern sector, northeastern sector, North Bengal, then South India, a lot of tea is produced. On tea processing, whatever we have done, taking that example, I'll try to explain what exactly is possible in the processing side. Now, I don't want you to remember any of such things, but please know, after tea leaves are plucked from the field, there are a lot of processes, and that is a industry, that is a factory, that's a manufacturing. And there, the process names are withering, rolling, CTCs, continuous fermentation, monitoring, drying, sorting, packaging, etc. These are the various processes. But actually, tea leaves, after being plucked, it comes to a factory. And in that factory, a lot of sensing applications are going to be highlighted in my next slides. So now in the first process called withering, we do monitor leaf temperature, leaf moisture, then time of withering, then hot air temperature, fan on off timing, ambient relative humidity, ambient temperature. You see, these are all the parameters that need to be measured, that needs to be monitored in a regular periodicity, in an automated or quasi-automated tea manufacturing system at the first stage. That is the withering point. And all these things actually need sensors and sensing systems. And we have exactly done that. And then next process, that is rotorven and CTC. In there, I have shown these two processes together. Whether total, there we need total mass delivered, total operation time, set and feed time and feed rate. These to be monitored and they have to be controlled also in an automated or quasi-automated system. So here also a lot of sensors and sensing systems need to be used. Then, so for rotorven and CTC also leaf temperature, CTC cut temperature, ambient RH, motor RPM, motor currents, they also need to be monitored at the same time. So these are the important parameters in rotorven and CTC. Then in the continuous fermentation machine, you have to monitor leaf bed temperature, etc. You can see that linear travel period, change in color. You see, in this process only, the green color of tea leaves change to the coppery brown color. And the smell, that is grassy smell, is converted into floral smell in this particular fermentation process. So here we have introduced the color sensors. That is, you have to monitor the change in color of the tea leaves also in this process by sensor and sensing mechanisms. Then the last process is dryer, where various levels, temperature needs to be monitored, relative humidity needs to be monitored, RH of even exhaust air needs to be monitored. So the point that I want to drive home is, suppose I am showing only tea processing. It can be a mango processing. It can be a processing of honey, or it can be a processing of some other food products. Everywhere there will be machines, there will be motors, there will be the input material, their feed rate, their color change, their other temperature change, parameter change, ambient temperature control, ambient RH control requirements will be there. So when we talk in the agri processing sector, application of sensors, you are talking of really automating a system and using sensors as the monitoring devices, and actuators as the controlling devices. So based on the sensor information, your computer will process what control needs to be applied. Now suppose some machine needs to move faster, so there has to be this decision support system will give the information to the motor that you have to rotate a little bit faster now. At this rate now, motor speed will be controlled. So sensors in an automated system will collect information. Sensing system will transmit the information to the computer. Then computer will process the information, and the control signal that will be generated, that will be routed back to the machines through actuators, and those actuators only will really make the process automated or semi-automated. So important parameters. So these are the same. Our experience with our model tea factory. We developed a model tea factory, totally automated in TRA Toklai, Assam, and these are the various important parameters and digital inputs that we acquired. So there is a concept of central control room. All sensors data from all the processes are aggregated there, and then the data processing algorithm run there, and the decision support system gives the output to control the actuators. This is the photographs. You can see right from input to output, this particular process is absolutely unmanned, controlled through. I'll draw your attention to right corner of the slide, which is on the first floor, the central control room, and the operator or the supervisor will sit there, and he or she can control the entire operation from that device. And this entire thing is powered by sensors and sensing technologies. So these are all various panels which actually communicates the signal to the central control room. These are various controlled and measured feed to the rotor vane. This is all, you can see the sensors, that is in the temperature sensor written there. And whenever leaves come out, temperature is monitored there. You can see that signal transmitters and are installed along with every machine, so that the parameters can be monitored by sensors and sensing systems. And then various other monitoring gadgets like carbon dioxide, oxygen, leaf temperature on the fermentation bed. This is on the fermentation bed. So this is the parameters on dryer, and you can see this various temperature sensing, relative humidity sensing is being done, and this entire process then only gets automated because these sensors transmit all the data to the central control, and the whole process becomes most automated process. So this is the three-tier architecture for any processing. For any processing in agri sector, suppose some fruit juice making factory or some I don't know, I'm not habituated with a lot of food processing industries, but many of you may know. So in food processing industries, the process has to be understood, sensors have to be decided, points of sensor installation has to be finalized, sensing systems has to be optimized, data communication protocol has to be decided, and then from a central control, you can really implement Industry 4.0 in your agricultural processing sector, because this is what is intelligent automation. This is not automation powered by high level of mechanical engineering, high level of electrical engineering, but this highest level of AI, ML, and information technology powered by sensors and sensing system in the front end. So this is another tea factory. We did automation, similar various sensors. This is in Tripura. This is in process, how the temperature sensing and other sensing is happening. This is the tea factory at Brahmakunda. That is another tea factory. We have a little bit customized because all factories are not same. So we did in different kind of sensor arrangements in different factories, and they are all up and running as of today. So these are the software screens where the software mimic diagrams are available, and you can monitor online on a graphical interface the real data in terms of those particular physical parameters. Though these are the system features, this need not be told. So you, even for withering controls, what should be the rate of withering, etc., you can decide through systems accordingly. The hot air blow, then fan on off, etc., can be controlled, and that can have a real time feedback, closed loop feedback system to implement a particular mode of withering you want for a particular clone of tea. So that kind of system has been implemented, but that is not the focus of today's discussion, but the focus is you can control your process using appropriate sensors and appropriate control algorithms inbuilt into your decision support system. So these are all various system features, benefits. So one more project that we have successfully implemented very recently, I'll try to draw your attention, because while we say agricultural processing, we also thought that this is post-harvest storage also, because in post-harvest storage, a lot of sensor application is, and we have done a warehouse monitoring and management software for the FCI godowns. This is in Raipur, in the state of Chhattisgarh, where we have done all kinds of environmental and this ambient atmosphere monitoring using temperature and relative humidity, etc. And of course, in this kind of storage, there is something called fumigation, and fumigation is done only to get rid of insects. And those fumigation monitoring is not done. Generally, they use a phosphine tablet and fumigate the system and do it after 15 days once again, or in a very subjective periodicity. But here we have developed a system where the fumigation effect is monitored, how long that effect of that gas is present in that particular atmosphere, and as soon as it reduces, then it gives a signal so that you have to fumigate it once again. to keep it free of insects. So that's how this is a project we have already implemented, and including fumigation monitoring and all kinds of atmosphere monitoring. And then another ongoing project we are working with CIAE Bhopal, that is for electronic sensing system for safe management of potato, onion, and tomato in storage. Now, whatever we have found that for this kind of crops in storage, if some damage starts happening, then obnoxious smell or undesirable smell starts coming in. And here we are using electronic nose technology. We are using these metal oxide sensors to periodically smell what is happening within the storage. And if we find that traces of obnoxious smell started coming out, we are able to locate that particular position and dispose of those materials early than the other stored material which has not yet started rotting. So this is a very unique and innovative project using, once again, sensor and sensing technology. And sensor and sensing technology together gives a machine olfaction system as output, and that machine olfaction system is capable of finding out what is the status of storage for potato, onion, and tomato. So last, I have been given marketing also to talk about. So sensing technology in marketing, I told marketing is all about quality, and quality of agricultural produces, believe me, all these days have been measured very subjectively. You measure whether this apple is good. I told you this potato is bad because it's little soft, but it is all human dependent. Now sensors and sensing system can intervene and make all kinds of difference in really finding out the quality. So these are the various products that developed by CDAC for objective measurement of quality of agricultural produces. Just one moment. So these are the various products. I have taken a lot of time. I think I'll finish within, be assured I'll finish within 5 to 7 minutes. So this is one electronic nose and vision system for quality of tea that we have already developed and commercialized. There is a vision system which finds out the color, uh, shape, and size of the granules of the tea, as well as the color of liquor for a particular tea, and the aroma of the tea also together. And this kind of system has already been developed. We have a handheld variant of electronic nose that is used for quality estimation of cardamom, quality estimation of lychee, quality estimation of chili also. And we have deployed in a number of locations that is being shown here. Then assessment of jasmine flower fragrance, because jasmine is one of the very important cash crops for our southern part of the country, and extract of jasmine is called concrete, and that extract is exported to France to make very costly perfumes, and that quality is estimated by this this electronic nose that has been developed by CDAC, and this is with Tamil Nadu Agricultural University. Then we have developed a portable electronic tongue which can find out taste of various beverages, including the quality of water also. Then electronic tongue we have developed for the quality of tea. This is also commercialized and used by a number of tea industries. Here we use electrochemical sensors, voltammetric sensors, an array of sensors, not one sensor, which senses the various test parameters of tea liquor, and that can be objectively measured using such devices. Then we have done electronic vision system for cooking quality, and that is alkaline spreading value, amylose content, gel consistency, elongation. These are the various parameters for rice, and we have developed an electronic vision system, and that system also is under use in IARI and a number of other state agricultural universities. This is also direct example of sensor sensing system that can measure objectively the quality of rice, and that is the first step of agri marketing, any objective measurement of quality. So enos for aromatic rice we have done, because there are a lot of aromatic rice available in our country, and objective evaluation of how strong is the aroma and gradation of rice based on aroma, that can be done by this kind of systems. Then another one series of systems we have done where the rice or any pulse, the size, shape, have any defective grains, then length by breadth ratio, then broken rice, etc. That can be physically measured by electronic vision. Here sensor is camera, and then sensing system is the whole software and hardware together that has been shown. This is being used by a number of FCI depots during their this arrival of rice from various millers. They use this system to find out the price of that rice. There are 9 quality refractions of rice that can be measured with this system, and that system can be made uh, made customized for any other pulses and food grades. This is pulse view for the tur dal, etc. That is the quality measurement system using sensors and sensing systems. This is CT view system, that is chili and turmeric. A number of such systems are now used in South India, in the state of Telangana and Andhra Pradesh, where chili is a very important cash crop. And chili trading, chili quality was subjectively assessed by human appraisers. Now this is done by such machines. I think more than 25 machines are in operations now in the chili markets in Guntur area. And this is something on silk color grading system. Sericulture also is part of agriculture, and the silk hangs produced in Tasar sericulture, especially in the state of Jharkhand. And there we have used such Resham Darshan system where sensor is once again camera, and color matching, color palette has been developed, and color matching is done based on the software that has been developed for this purpose. And this system also we have commercialized. Then micrographic image analysis. This is also for the sericulture sector. There are pebrine spores are there in the moths, and that conventionally is done by microscope by tribal people. We have used a digital camera over the very cheap microscope and developed the software so that very easily they can find out whether any moth is affected with this kind of disease or not. We have developed once again the quality of apple by acoustic testing. This system has been developed and now deployed in Sher Kashmir University in Srinagar, and one more season of data acquisition will take place before commercializing such system. But this uses vision as sensor and microphone as sensor, and there is a spring-loaded hammer which gives a tapping on the apple, and the sound is captured from all around to really find out the desirable frequency. and with the data acquired over a season, we will train the machine learning system so that AI algorithm can be developed to really declare which apple is good and which apple is bad. So this is Apple Sense system internal view. And I have come to the almost end of this thing. So there are some biosensing system we are working. Biological sensors are used here. Here, stimulus is biological, like enzymatic sensors we call, and there a pesticide residue system we have developed, pesticide residue monitoring for tea, because there are some MRL limitations for pesticide residue, and there, if you put the pesticide spike samples onto our receptor, which is an enzyme-based receptor, then the transduction takes place and current is measured. And there are two ways. One is electrochemical way and one is colorimetric way. Both ways we are exploring, and this also we perceive to be having a very big scope in days to come in the field of sensors and sensing system. Biosensors for fish pathogenic bacteria is another project we are working on. So I have come to, I will not extend my talk anymore because I know that I have crossed the threshold of attention model of all of you, and I have been talking continuously. So I end here only telling that sensors and sensing systems are going to be and remain to be the very crucial part of any advanced system that we are going to develop in days to come in the field of agriculture in terms of application of ICT. That's number one. Number two, sensors can be physical sensors, chemical sensors, biological sensors, electrochemical sensors, so and optical sensors, acoustic sensors, so on and so forth. And then last but not the least, sensors for taste and sensors for smell. So all kinds of sensors for optical vision. So all kinds of then sensors for touch, then sensors for uh, any mechanical movements. So all kinds of sensors. There are commercial sensors available in the market. Few of the applications, but many more sensors need to be developed worldwide and in our country to really make the applications coming to life in the field of agriculture especially. And please note that once sensors are there, then the following technologies are also equally important, and they include the communication technology, IoT protocols, Internet of Things protocols, Internet of Things technologies, then communication technology. Once it is proven, it goes to a server or a computer system. Now, there the cyber physical technologies coming to work, where the artificial intelligence, machine learning, then big data analytics, then uh, uh, there may be even this your augmented reality, virtual reality, then robotics is one of the important things, drone technology is one of the important things. All these technologies also one needs to keep an eye on, along with sensor and sensing technologies, to deliver something meaningful on the ground for the field of agriculture. So with this, Professor Jha, I am done because I started 15 minutes earlier. So I don't want to continue any further because people must have been already bored with my continuous talking. So I thank you very much for listening. Yes, sir.
Sir. Thank you, sir. Thank you very much. all the. I am audible. Please give a big hands to Dr. Bhattacharya. You could have just guessed how he is in the field of technology and organizing committee, and on behalf of participants, I acknowledge your contribution to our program. Thank you once again.
Everybody has to switch off their mics.
Now,
Yes.
sir, you have given ample time to address our participants, and I am very much hopeful that with your experience, they must have been benefited, and in days to come, they must be implementing some of the projects for the benefit of the farmers and agriculture. I thank you very much, sir. And it is our privilege that whenever we make a call to CDAC Kolkata under your leadership, we get a quick response. Thank you, sir. Thank you.
Yeah, so please give them a small, at least 5 minutes break after this long talk.
Okay, sir. 1 hour break is there. 1 hour break is there.
Okay.
Participants,
thank you very much.
Session will start as per schedule. Thank you, sir. Thank you.
Okay,
Thank you.
I am going offline.
Interrupt here.
Okay, sir.
Somebody wants to
interrupt here.
Yes.
Yeah.
Yes. Yeah, Dr. Vikram from ICR headquarters.
Yes.
Yeah, sir. Please respond. Yeah.
Sir, you have explained some of the technologies which are already commercialized.
Yeah.
First of all, I'll congratulate you. And second thing, I am interested to know that to whom you have commercialized these technologies.
So I can share you this. There are a couple of industries we have already commercialized these technologies because more than 5 technologies have already been commercialized. I can share you the list.
Because it will be useful. It will be useful because at ISRI also ICT based technology commercialization may be helpful from that side also.
Yeah. I am in touch with ISRI, and actually CDAC is in negotiation with Dr. Anil Rai and Chaturbedi sir also.
Yeah, Dr. Anil Rai is now ADG ICT also.
Yeah. We had a meeting only maybe 7 days back, and we are going to sign an MOU also. That CDAC is going to sign an MOU with ICAR, and we have already identified 3 areas where we will deploy all these technologies, and there CDAC Kolkata and CDAC Hyderabad, we are working together along with CDAC Pune to really give a big push in this area. So I'll certainly share with you all those details.
Sure, sir. It will be a good thing because Agri Innovate, ICR is having a separate company for commercialization activities. And in ICT sector, if something is there, that will be useful to share here.
Exactly. Agri Innovate के साथ ही करना ठीक होगा वो.
Sure, sir. Dr. Sudha is there, and we are working together. But
yes,
you can
share my email ID with them. My email ID is available with Professor Jha, or if you can, my email ID is there in the comment.
I can discuss with Dr. Rai because you already had meeting last week.
Yeah. Rai साहब के साथ बात कर लीजिए.
Then it's okay. Thank you very much, sir. Thank you very much. Thank you, Jha sir.
Thank you, sir. Thank you. Now we are breaking for lunch, and we will assemble as per our scheduled time. Okay, thank you. Now I'm just closing the meeting.
Yeah, I am going offline.
Okay, sir.